Now we are. Okay, so continuity for us, if you're going to prove mathematically that a function is continuous at a given point, there's three things you're going to have to do. Okay? So, to prove or show, whatever you want to think of it, to show a function is continuous at a given c value. I will use c as our x value. And there are three things. One, f of c must be defined or exist. So in other words, when you plug that number into the function, you have to be able to get a y value for that function. Okay? Let's say I was using this function right here, f of x equals 1 over x. And I would ask you to show me whether or not this function is continuous at x equals 0. Well, automatically that wouldn't satisfy this step. F of 0 is not defined here, right? If you plug in 0 to this function, you get undefined, you get an error, right? So you got to be able to take the value and substitute it into the function and get an answer for y. So it has to be defined, otherwise it's impossible for it to be continuous at that given point. That makes some sense? Okay? Alright. Step 2, the limit of the function must exist. The limit of the function as x approaches c must exist. Okay? When do limits not exist from what we've seen so far?
They approach different numbers from each side.
Yeah, so as I'm coming from the left, as I'm coming from the right, I'm not approaching the same y value. So the one-sided limits don't match, basically, right? Okay? If that happens, all right, the function, I mean, that should make some sense. If they're not approaching the same value, how can that function be continuous? There's no way to connect them, right? You'd have to move your pencil off the paper and then start drawing the rest of it. Okay? So the limit must exist. And then the third step, which you kind of do with part 2 in a sense, but whatever you get for this answer has to match what you get for this. So in other words, f of c must equal the limit of the function as x approaches c. So in steps 1 and 2, you're just showing whether or not f of c is defined. The limit also has to exist. And then step 3, to prove or show that a function is continuous at a given moment, you would need to show that whatever the value is for 1 has to match the value that you got for 2. If you can show me those three things, you are proving to me that a function is continuous at a given moment. Okay? We'll do an easy one here together. Show that f of x equals x squared minus 3 is continuous at x equals 1. It's very basic. Step 1, f of c must be defined. So f of 1. Do we get an answer for this? What is it? -2, because when I plug 1 into the function, I'll get -2. So it exists. Step 2, what is the limit of the function as x approaches 1? Well, we talked about how to evaluate limits analytically. If possible, we just take this number and substitute it in, right, to get our limit, which we can here. And again, we get -2. So the limit exists. And then the third step, we can now look at our first two steps and say that f of 1 equaled the limit as x approaches 1 of x squared minus 3. So all three of those things checked out, and then I would put it in writing. Therefore, f of x is continuous at x equals 1. So this is kind of what I would expect to see when you guys are asked to show whether or not a function is continuous at a given moment.
So for 3, 1 and 2 have to be the same?
Yep.
Or?
Yep, exactly. Perfect. For this to be true, you better have gotten the same two values for 1 and 2. And all step 3 is just saying whether or not they work. Okay? Now, you know, if you had this going on, okay, let's say we had a piecewise graph that looks something like this. Okay? And this, let's say this is our C value right here. Does f of c exist? Is there a value for f of c? Yep, right here, right? So we would have gotten an answer for 1. Does the limit of this function exist as we approach c? Yep, it would be whatever this value is here. But step 3 would not work because why? Yeah, we got different numbers. For number 1, we got a negative value here. For number 2, we got a positive value here. They did not match. Okay, so I would put a little, well, in my proof I would draw that, saying they don't equal each other. Okay, and therefore the function is not continuous at c. Does that make sense? For one that wouldn't be, then? Okay? Alright. So any other questions on showing something is continuous or not at a given value? Alright, good.